Hi everyone! Today we have a unique video on the channel because Looper Robotics sent me their camera Insight 9 for review. They send it before official start of sales for this camera and allow me to do fully independent review. I'm super excited about this, so let's dive in. First of all, let's look at this camera. Does it have something similar to this board, which I already have a review on my channel? Actually, yes, because this board is the core of this camera, what is running all the inference and creating 3D depth estimation. You may say, wait a second, is this camera like streaming depth? Yes, instead of a lot of modern cameras, it has NPU inside, which is processing video and streaming directly depth. I already had one such camera on my channel. Of course, it was OAK 4D. This is the second camera with these capabilities, but solution is completely different from what OAK has with their camera. Let's start from this board. Shortly remind you what is it. This board has 10 TOPS NPU inside, which can run neural network with int8. In my review about this board, I mentioned that this NPU it's not super good because it could run only int8 neural networks. It could run only neural networks with pretty simple structure, and their depth network was not super great. Here, guys solve this problem because they just collect a lot of images from their specific camera and retrain this network specifically for this camera. And quality became much better. We will check this a little bit later. Let's dive in and look a little bit on this camera. This camera has two connectors. One is classical USB Type-C, and the second, there is no information in official documentation, but when I asked Looper Robotics about this connector, they mentioned that it's synchronization. At least in future, we could expect some synchronization of this camera with different. Here on the top, we have a mode switcher. It's also not in the documentation right now, but of course I asked this question, what is this? And this actually pretty interesting. I will return to this a little bit later. Let's look on thermal balance of this camera. Actually, it's quite nice. It's comparable with OAK cameras when they run in some inference on Myriad chip. Here, it's the same 50 degree. Yes, it's a bit uncomfortable to take this camera with your hand, but it's not like burning through your skin. It's possible to take it. I ran this camera for a few hours straight, and the temperature was super stable after this few hours. Let's speak about this interesting button here. When I was reviewing this camera, they did a lot of stuff with ROS 2. ROS, it's like Kafka on steroids for robots. Or you can call this like CAN bus of auto, but for robots. So it's a system which creates independent users in your network and allow them to communicate with each other. So basically, when you're connecting this camera, it's create a LAN device on your PC and hosting a few different services. One of them can give you information from depth camera, the second from left camera, third from right camera, fifth from RGB camera, and also a few topics for additional information. I don't like ROS myself a lot, but I know that sometimes there is nothing except ROS. This solution is pretty interesting. In the world, there are a lot of robotics engineers for whom this ROS packaging it's actually pretty okay, and they used to this. For them, probably it will be reasonable. Also, this ROS packaging can give you pretty nice streaming out of the box. So out of the box, this camera provides pretty stable protocol. What is the minus? Sometimes ROS can fall on your PC. For example, on my PC, there was a few issues when this ROS just freeze on my side and I couldn't even restart it. but it's not this camera fault, it's mostly ROS fault. And let's return to this button. At the moment, it's only possible to host this camera as a ROS device, but they promising then in the next one of the next release, they will allow this camera to communicate as USB camera device. So probably they will just create a few independent USB cameras. In my opinion, it's great because for a lot of applications, USB camera would be better than ROS. In some application, actually this ROS packaging, it may be better than classical USB camera because, again, a lot of robotics engineers, they working with ROS directly, and for them they even like creating these ROS wrappers around normal cameras pretty often. Let's go deeper and look at the depths. When I was reviewing OAK for the camera in my last reviews, I always mentioning, why are you doing depths like this? You can do it completely different, and in some situation it will work better. And here, this is like this. So let me explain. When you have two cameras and you calculating depths from them, of course, there are some region when only one camera can see you, like this. But different camera can see you and one is not. In such situation, it's impossible to estimate depths properly, but sometimes you can estimate depths on base of some information. For example, like if I close this camera partially, it knows something near the camera, and it can estimate, because today you can estimate depths with these monocular cameras. And of course, it's not precise. When you're looking on the depths that created by OAK camera, they pretty specific that they don't want to give you incorrect information. And they just filter in all this information outside of this field where both camera can see you. Here, they doing differently. They just train neural network that it's providing straight stream. And of course, you can easily trick this. So just check these videos that I generated in a few minutes. On one video, I'm just closing this camera and showing how it behave. Here, what is happening when you moving camera too close to your hand. And for example, I like this. I just showed this image to the camera, and then I tried to move camera in, and on some distance, it's starting to generate this depth image just from monocular estimation. So you will have a lot of artifacts with this camera. But actually, maybe it's not so bad, because in a lot of situations, you need some estimation, and having estimation is better than not to have it. I really like this philosophy. In my opinion, best camera should have both of these algorithms, because you need like a switcher. I need measurement accuracy because I need to measure everything, or I need accuracy that can provide me coverage. And sometimes coverage is all that you need, and especially in robotics, and especially in some navigation. And this camera, it's really more about robotics. And let's discuss this depth quality a little bit deeper. As I mentioned, they just fine-tune a network. But what the network is used here? StereoNet network, which is pretty old. And of course, this network, it's not creating a great quality. You already saw such issues with close zone, far zone, but it's also create a lot of artifacts. For example, when between some close objects, it's create a lot of noise on borders. And it's like, of course, it trade-off when you're using such old networks. But in my opinion, it's not bad for such old network, because when I run this network on Halo, when I run this on some other boards and NPU, usually quality was terrible. And when I checked even my materials from RDK5, it also was not great. But here, actually, quality it's okay for me. And for a lot of application, I think it will be more than enough. Let's move further. As you could see, the depth image of this camera is a little bit strange. It's like vertical. Why is it vertical? And here is the third big difference of this camera, because it's creating depth from 180 degrees cameras. And of course, like they overlap. So basically you have square image from each camera, and when you correlate in them, there is a part that it's outside of both cameras, and of course your image became vertical. And I think it's the only stereo camera right now on the market which has such wide field of view. When I discuss this question with a few of my friends, a lot of them say, no, of course, we never use in such cameras. But for other people, especially in robotics, when I ask them, like, what do you think about this feature? They said, oh, it's a great feature, because for robots, I need this field of view, what is happening outside of my robot. Of course, it's a decision, and all decisions in their camera, they make in this camera different from all other cameras on the market. And this is what I like about this camera. It's totally different camera in all aspects. Also, I did a few different measurement of depth. So first, I estimated accuracy. And of course, it has like this graph which estimates an accuracy, but I think it's a good idea just to check on higher level if it's correct. So I did this stupid test with ruler and this camera, and yes, for each distances like up to 1.5 meters, I have accuracy within 2 centimeters of defined. It's cool. In their graph on their site, they mentioned that they are more accurate than RealSense cameras. And okay, it's pretty easy to be more accurate than RealSense. But what they hide in here a little bit, they a little bit less accurate than OAK cameras. Because for OAK cameras, this graph is looking a little bit better for them, in my opinion. But again, it's comparable accuracy to modern cameras, and I even a little bit curious how they achieve such accurate performance when they have such wide angle lenses. And as a next point, I want to check latency on this camera. And actually, it's super interesting because latency, it's what you really need in your robot. What I did a classic glass-to-glass test when I just put camera on monitor where I run clocks, and I just looking on different images, like I streaming video from this camera and I looking difference between them. It's allow me to estimate latency of RGB camera. As far as I could estimate, it's something around 200 milliseconds plus minus 40 milliseconds. It's actually not the best numbers, and I think that ROS here may be one of the issue. And the second issue is that we don't have like direct communication with camera. There is a RDK board between us and direct camera, and this is what creating additional latency. So basically, first this RDK connected to the camera, then it's pre-processing, then it's packaging this, then it's streaming, then we are through ROS, then we are unpacking, and this is pretty long. So I expect then when there will be a version without ROS, it could be a little bit faster. It definitely will be not like beyond 50 milliseconds, what in my opinion holy grail for such camera. And also I estimated latency for depth estimation camera. In my opinion, it's additional 200 milliseconds to this RGB camera. So the full latency for this depth, it's around 400 milliseconds. It's less than a half of a second, but it's not great because it's lower than human reaction. And of course, if you build it something from good cameras with maybe 50 millisecond latency and you run in your own StereoDepth estimation network within another 50 milliseconds, you can get this StereoDepth within 100 milliseconds. But for out-of-the-shelf solution, actually, I don't think that it's worth numbers, and it's like quite okay. Let's speak a little bit about usage of this camera. So actually it's pretty easy, but they don't have in their official documentation all guides about ROS installation. So I did it like this, and it's worked for me after a few iterations of communication with ChatGPT. So when you will work with this, don't expect that it's like an easy walk, because this ROS, as I want to mention again, it's not super user-friendly interface. So ROS out of the box didn't work for me, and it's required this additional installation of Cyclone packages, and after this it started working. The other issue that I had with installation, it's hardly required to you to use their cable. It's like looking a little bit unique, because when I tried with a few my cables, which already were connected, and usually everything is working through them nicely, this camera didn't work with them. Maybe it's like quality of the cable, but again, it's something they worked for me previously. Or maybe it's just I'm unlucky. So with their cable, everything worked fine for me. By the way, I have an article on Medium where you can copy all this code and just use it yourself. Also, there are a few pretty interesting moments about this camera. First of all, in their manuals, they was mentioned that it has on-the-board SLAM. And also for this RDK X5 board, there was onboard SLAM. But when I checked official documentation, they recommend you to use some third-party vendor of open source algorithm. I didn't test it yet. Maybe there will be some different video from my side on this topic, because I want to check this. Also, guys from Looper Robotics mentioned to me that there will be from their side. Let's go to my thoughts. This camera, it's not better than OAK cameras, for example, but it's completely different. So this camera is looking on this task of receiving 3D images from perspective what a robotics expert want to receive. And for a lot of robots, it's definitely interesting to work with ROS directly. It's definitely interesting to receive like full view. It's super interesting not to think about which algorithm do I need to use for my stereo depth estimation. They just want to connect to this camera and receive some depth images from this camera. From this perspective, this camera works great. It's the first out-of-the-box solution where you have pretty nice out-of-the-box depths, where you have pretty nice quality of the image. It's something completely different, and it's great they created this camera. Thank you for watching. Again, I'm super grateful for Looper Robotics for ability to test this camera, and we are living interesting times. Thank you for watching. Bye.